And the topic I was given because I didn't had any choice. It's always there, right? If a friend calls you, you have to do what he say, right? So it happens to be like this. I don't had any choice of just saying yes. So the topic for today was assigned to me was something very broad and interesting to sit and discuss. I'm not going to teach or tell you something new over here. Please don't do have big expectations. At the same time, what I'm going to give you or take away what I was expecting before making this presentation was because I'm doing on this particular talking about South Asian geohazards itself is something not easy. I don't think so. I can even talk even after 20 years of doing research in geohazards on this particular topic. Okay, so please take this as a disclaimer before starting my presentation. And coming to the other aspects, infrastructure, if you look at the title, I just added a little bit because Codal provisions in South Asia was the topic given, so I added for infrastructure projects. I just want to start with the keywords that I picked up from this topic. One is like codes, okay. Second one in a larger area, which is I can say that the hotspot of all kinds of geohazards. Because if geohazards happen, obviously whatever you build structurally has to go down, right? There's nothing which can take if the soil or the geomaterial fail. So the structure should either fail or fall or even fly also. We don't know. So whatever the case, so geohazards are very, very important. And since all of us are belonging to the South Asian countries, so where we have an interest and we also have a equal responsibility. So the takeaway for my presentation, I don't have many slides, I have around 17, 20 around. So the takeaway will be what we learned in the past and what we are looking forward in the future. What is the societal demand? That's what I would like to discuss more. Finally, end of the day, being a civil engineer, we have a huge responsibility when compared to the other engineers, right? Even I personally feel, don't take me that I'm advocating geotechnical engineering. I'm sorry for structural engineers over here, if any. But I feel among entire civil engineering, geotechnical engineering has more and more responsibility. Okay, because everything is on the ground, has to be supported by the ground, and be sustainable with that. So another issue I would like to take away, which I'm prepared to discuss with you. Kindly stop me if you have any point. I'm here to learn from all of you, your experience as well. So the second point is hotspot with respect to several, and nowadays because of climate change, the designs what we have been had before, the codal provisions what we had before are not working at all because we are getting so many surprises, right? And big surprises. If you are aware, anybody from Indian perspective, or if you are even, we had a major Dauli Ganga event in February 2022. So it was like a multi-hazard. Like there was a glacial outburst. We really don't know where it was. And then because of that glacial outburst, there was a huge flood kind of activity, rockfall, and then, there's a dam fail. Okay, so there is a hazard chain, right? But if you look at our codal provisions, we are targeting if there is a seismic activity, okay, do this, ground motion parameters, ground response analysis, liquefaction, everything, soil structure interaction, etc., etc. What if I have earthquake plus landslide, or like I have a rainfall in monsoon, then snow in winter, then there is a microseismic activity, right, which is a combined hazard, right, and then there is a landslide. So when there is a landslide, it's all about the pore pressures, and they're already piled up, right? A micro seismic activity of 2 magnitude can also trigger a big fail, right? So how are we handling that? Okay. So another disclaimer I just remembered that codal provisions are just guidelines. Okay, at least I'm talking from more of Indian perspective because I'm a member of the BIS committee and I'm also working on landslide monitoring code, which is in the draft stage. Okay, I'm working on that. And we don't have such monitoring code across the globe. So maybe we were the first ones which were coming up with new codal provisions on landslide monitoring specifically, in addition to mitigation. So that's why in that capacity I'm trying to bring this disclaimer as well. If you have any other perspective from your own nation, please let me know. Okay, I'm here to learn as well. So code is just a guideline. It's not mandatory. At least to geotechnical designs, it's not mandatory. Why? Because we need to be more creative, and we have too many options also, right? And sometimes nowadays, not just only the safety concerns, economics also plays a very crucial role if you would like to call yourself as a good design engineer, right? Or good geotechnical engineer. So economics always plays, because I'm working on one project. Actually, I'm consultant to 6 airports in India. One of that is a tabletop airport, and I'll try to bring some of my project experiences as well, so that where we are going just outside the boundaries of these mandatory guidelines. Okay, so it was a tabletop airport in Mangalore, somewhere in the southern part of the country, and there was a lot of sliding activity, and now they are going to build a MLCP. Okay, 6th level with 2 basements. You can assume that 6th level, 2 basements, and such a tabletop landslide. Okay, so a lot of things. So the contractor is one of the big contractor, Adani Group, maybe in the news recently. So we already designed something for the mitigation, but they again coming back and forth, because this is the rock bolts are and the nails which we designed was around 24 meters, because taking care of because at the toe part there is an engineering institute college is there. Okay, and there is a hostels and there is a risk associated. So when you design it, it is why I said it is all about combination of your judgmental parameters, right? It's a judgment. Finally, end of the day, design is a trial and error, and it's a judgmental based, and all depends upon how creative you are. And I'm sure that all geotechnical engineers sitting over there are very, very creative, because I feel myself I'm very creative. Okay, so and the second keyword, I talked about the codal part of it. Second part is South Asian countries. We are sitting with on landslides, we are on earthquakes, tsunamis, floods, and whatnot. Like, we have everything, right? So let's put our mindset before starting the presentation. I am dealing with a multi-hazard, okay, and the risk associated with a multi-hazard. So I think I saw this message number 1 here on the pin board. Hazard, risk, vulnerability, and this exposure. Very good, right? So I will be dealing about the which is in the center part, the risk associated areas, because if a landslide happens in very remote area, nobody want to worry about it, right? It's natural and there is zero risk, so I don't worry. So I'm only worried about the areas which is having exposed, okay, which are vulnerable and having a higher risk. Okay, so I had 4 vertical. If I can use my tab also, I think I don't need to change it. Okay. Okay, I'll take it. I'll just leave it. So I have 4 verticals. Why I said this concrete pivotal role is like personal, farmhouse. So these are replacing the steel, right? So, and also similar to concrete, in previous years, because most of the codal provisions has been prepared 15-20 years before, and of course revisions are, I'm talking about Indian perspective again. Okay, please take in that sense, because I'm also working with understanding the other codal provisions as well to improvise our BIS codes. Another issue was here is like in the past 15-20 years, whenever these codes have been made, and most of the mitigation measures also takes concrete, because you cannot avoid that material as of today's scenario. And another issue is previously they were used to place concrete. Now they are pouring concrete. There's a lot of difference, right? So changes have happened, and even in the concrete also there are a lot of material strength, and also a lot of research went, even including microbially induced concrete kind of, which has long term for crack propagation. So a lot of work is going on in the I think it moved to the next slide. what are the guidelines for safety? So these codal provisions, they provide guidelines, as I already said. It's a framework. It's just a guideline. And what I have to do as a design engineer, I have to verify it. What I can take it up as per that. But it is nothing mandatory. There is a lot of confusion or the myth, even in the design offices in India. Okay, so as if like this is what code says, and sometimes we deal with a lot of clients. Like there's a client, especially from government clients or somebody. They say that sorry, sometimes I'm getting Hindi. Excuse me, but because I feel I'm at home, right? So they say that no, this is what is there in the code. You must follow this, and no, it's not like you always have to debate that. You always have to convince them. As a consultant, I have, if I'm talking from the client side, or from the contractor side, so I have to deal with these kind of things, because this leads a lot of arbitration also that's happening in the country. And for safety of my whatever the structural components I'm taking care, and there is a need for very new generation codes. I think we should all work cross boundaries, because everything, at least in South Asia, we all have to work very closely cross borders. Why? Because I have my research students who worked on Himalayan regions, especially on the landslides and the tunnels in the mixed Himalayan geology. So this is all same, right? The geology, geomorphology, seismic things are all same, right? We made this administrative boundary. So in that aspect, I think it's going. I don't know why. Okay. So then how to balance that? And as I said, because in the last 20 years, a lot of knowledge sharing has happened, in several forms. So a lot of balancing between the global and the local. I'll take one example of this. We have high-speed railways are coming up, trains are coming up in the country. Mostly we are taking, the technology from the Japan. Okay, JICA consultants are a part of it in India. It's a huge things are coming up in terms of infrastructure. One of such vertical is high-speed trains. In the high-speed trains, when the designs are coming from the Japan, they were failed on the Indian soil. Okay, Indians, they could not do it, and they just left. The design company could not do it for the Indian soils. And how come? Japan is such a very good with their construction or the design of high-speed trains. How come the designs from Japanese companies were not able to? Finally, Indian companies has to work, because there is always a local material, right? The behavior, the dynamic behavior of this material has to be properly analyzed and do it. So what I'm trying to say is okay, you have a good practices. I also welcome all of you for the last day 29th STC session of ISSMG, which we are doing it. And thanks to Mandi for giving the slot in that in this such a hectic Geomandu conference in 2024. I request all of you to attend that, because these are some of the important aspects, what we had in the past and what we are looking at the future, how we are going to handle the challenges in the future with taking care of the societal demands is something which we are going to discuss. So we always have to have a balance. Okay, what is that? And so in the high-speed trains also, so many discussions, and several groups, contractors, big contractors, and government, Indian Railways. So everybody has finally, they made their own thing balancing this. So that's why I just put it up. We have to have a challenge, but always taking the international standards. You should also have a proper knowledge of the international standards as well as your local guidelines. Okay, so then you can balance to meet the regional needs. So let me go to how this evolution of this infrastructure codes happens, and to start it, so the code is actually, as I said, it's a design is a trial and error. If you see from starting from the Tajagi's, classic soil mechanics principles as well, from that it's all been empirical trial and error. If this based on some case study, if this is works, okay, fine, I'll take this, and this works. So whenever, actually, as a teacher also, whenever I talk to my students, I always ask, you have an empirical equation, there is 1.5 factor. So you should know how this 1.5 came. It's not somebody's magic number, somebody's dream or two. Okay, you have to understand what is the rationale behind every number in any of the empirical equations, because there is a lot of things went behind that. So that understanding as an undergraduate student, so it's very, very crucial, of course, for every one of us, because just blindly taking care of, okay, this is 1.6 CNC, blah, blah, blah. So we had a lot of empirical equations, and we do with empirical equations there. And this empirical equation doesn't evolve just like that. There's been made after some failures, right? After taking huge amount of data, okay, either in the lab or in the field or in the model studies, whatever it is, people have done huge amount of data set, And from that, they evolved at the empirical equations. So evolution of these minimal regulations, like, okay, so if I'm just giving, if there is a soil is liquefiable, okay, based on this past case study, past failures, because whenever there is any hazard, either liquefaction, any earthquake or landslides or even tsunami, a team of people from a government representation, they go to the site, right? It all happens, like even earthquake also. Some of my professors were here, and I was also there just before, just after the earthquake, but it was very quick. And I witnessed like so many historical buildings. It was, because I just had a conference here. Ranjan I was one of the speakers, and then there was an earthquake, and again after earthquake I came. I see that some of the monuments which we literally lost. So it's really very painful. So why this kind of things, like you have a liquefaction and then something building has been there liquefied, so some tilt, so based on that I can say, okay, this is the limiting condition, okay, this much settlement I can consider as a threshold, right? So these are all based upon the past case studies. So whenever any hazard happens, whenever any failure happens, we have, because if there are a lot of reports also, kindly go through that if you're doing your research, etc., because that is actually very important document to learn a lot of things. Because I always like some failure photos of buildings or ground or something, because it's not because I like damage or something, it's only because there's a lot of learning to there. Like a simple example, if you have a crack on the wall, so we can understand where is the tension, right? Perpendicular to crack, there's a tension. It's a simple mechanics or simple physics. So if you have that kind of, then we'll understand what exactly happened at the ground, right? So going to the field. So if you happen to Wenchang earthquake, there was a museum in China, and Wenchang, when it happened, they made that entire city into a museum, right? You can walk around the streets, the buildings, whatever collapsed, they restored it. So such a learning experiences we have both in the literature and it's also in the field. So that's how we started that. Then there is a lot of technological advancements now, like we have in materials, we have a lot of advancements happened. Okay, people are using a lot of local materials nowadays, because sustainability is another vertical which we have to look at it, like how much percentage. We have this in Indian government, if you are doing, they'll ask you how much percentage of Make in India is going into this. Okay, these are all very, very important. Why Make in India? Because that is that material, whatever you are doing, it is made from the country, right? Local materials. That means you are, because local materials always been there in our construction practice since ages, right? If you go to the villages, they build houses with bamboo or local wood, whatever they are getting. I was just after Sikkim earthquake in 2013, there was an earthquake in Sikkim, which is again very between India border with Nepal. So this earthquake, when we went around it's a small villages were there, and when we went around the old houses which have been built with local knowledge. Okay, local knowledge is also very native indigenous knowledge. And also with the local materials like wood, they perform really well. But the buildings that have been done with the concrete, because you don't have a design engineer or a structure engineer in that region, right? So people build whatever they know it with the knowledge. So those buildings which are new buildings are completely failed. Okay, but if you look at the socio-economical aspects also, people have maybe the same with the Nepal as well, or mostly broadly in South Asian countries also. People have this key, if I build my house in a concrete thing and I feel like I'm advanced economically or socially in that setup. Okay, that kind of feel, rather than so. But if you look at the performance in that region, there is already local existing knowledge using the local materials as well, right? So whenever we are designing, try to incorporate that, what is the local, knowledge availability, and also, if you can adopt that, that is how it's been evolved in the code also. Okay, in terms of materials, like we have a lot of stone, material or rocks. Okay, already people are, and even the procedures also. Some of the simple thing I can tell you. I don't have that picture. There is an aerial picture of Indo-Kashmir earthquake. Okay, so there is an area called Muzaffarabad. In 2005, there was an earthquake. There was an aerial photograph of a part of Pakistan, and there are the masks. Okay, or some mask. Okay, so that building is very old. It's in a square shape, and something was in circular shape. They were performed very well. And other buildings which are very new, concrete buildings, residential buildings, they completely collapse, completely collapse. There is nothing except rubble. Okay, this is some. Why? Because they just maintained a symmetrical shape. It's nothing more. They had the buildings were on symmetrical shape. Okay, so symmetry is also very important to maintain. But other buildings which they are not, they are asymmetrical in terms of geometry. I can see that from the just a aerial photo. So this is a small issues which have been followed in the past, which we can incorporate. But now people want a fancy, okay, like star-shaped houses, X, Y, Z, all kinds of asymmetry. Just if you can ignore that, if you are sitting on a seismically vulnerable area, let's ignore that, go for a symmetrical. That itself, help you to be more, sustainable kind of practice. So these kind of small things applying here, because we always design engineer should have basic common sense is the most important thing. I personally feel you have to apply that. So whenever you go to, because we lost it, because we already trained our mind with all equations, all maths, all data, and all things like we sometimes forget to apply that with a human thing. So if you can apply that, we will be the best designers, I feel. Anyways, and technological progresses, like in the process, don't forget the indigenous practices, indigenous materials is what I mean to say. Comprehensive code development, yes, I think every country, at least Asian countries. In India, I know that. So, being rigorous exercise. It also has two parts here. One is like not only research, okay, because code cannot evolve just like that. It has a background, right? There is a data. As I said, somebody has given empirical equation. They had a huge data, 2000 point data set, something like that. Then only they can build a good, power law, some empirical equation kind of. So there is a research goes on, and research in terms of materials, research in terms of analysis, and research in terms of design. So all the three levels has to go, because we always work in three different verticals as a civil engineer. The people work on the materials, people work on the analysis, people work on the design aspects, right? So, and then it evolves with the time, and so that finally to ensure the safety, and I just want to add along with safety and durability, sustainability now. Okay, so every time whenever you are looking at this is something, otherwise your projects are not getting that star, like if you are using good sustainable materials, we are rating that also, right? Yes, already US has this. So similar things India also is looking at it, not in terms of star, but in terms of percentage of how much material and what kind of indigenous things are going on. Shift in design philosophies. So design philosophies evolved from empirical methods to more specific semi-probabilistic approach. So I'll explain over here. As I said, like empirical approaches, because if you want to find out liquefaction potential, right? We have seed and Idris method. I think some of you might be working on that. But these are all empirical equations, like you just apply, okay, CRR calculations with whatever things, and we have a factor of safety. So that is a procedure which is a highly empirical. But if you want to, that is not sufficient. If you did that with whatever the guidelines provide in the code, and you got something design parameters, but you have to look at the site-specific conditions. That's what I was explaining for this high-speed railways of the Indian experience as well. So, because local material, site-specific is something which is very crucial in hazards, okay, in geohazards in more specific. Why? Because the soils are different, and the behavior is different, and enter the physics of the problem. Okay, if it is a landslide, the physics behind the landslide is again different. Landslide is very generic, right? You can have rockfall, you can have debris. My talk is on debris, I think day after tomorrow. So we have debris, we have deep-seated slides, we have flows, right? Many kinds of things. So if you understand, but every failure has a different mechanism. Physics behind that failure is different, right? Understanding the physics behind a failure may help me to make it more specific to that particular site. I can't put the same thing everywhere, like same problem, two persons come with a fever, so doctor will give the same tablet. I don't think so, because fever is an indicative parameter. That failure there is an indicative parameter. He'll check it up by fever, right? If it is infection or if it is something else, right? He or she will check that. Then only they do it. Similar to that, we also do when the two problems come with similar to kind of thing, then again you need to do the investigation. So site-specific ground response analysis or site-specific analysis, either probabilistic or whatever, deterministic, whatever, there so site-specific analysis with site-specific investigations has to go on. Okay, so यहाँ पे liquefaction हुआ, यहाँ पे so liquefaction happened here, liquefaction happened here. I can't give the same solution. Okay, because I'll tell you one more project. We had a project. They made 5 boreholes. At one borehole, there were 2-meter liquefiable site strata. If I look at only one borehole, I have to entire volume. I have to take care of it, right? I have to give a mitigation approach. But if I look at only that borehole, I can make it a localized. So it depends upon how well you know about your soil there to have it. So along with that, Codal empirical approaches, you also have to do site-specific study based on the project. And impact on current practices. So code, whatever the infrastructure, I don't know about other South Asian countries, but again, I'm going with the Indian perspective. You can't the scale of projects that's going on is like major. Like we have several tunnel projects, and the entire country we are having a Bharatmala projects where like several tunnels, several bridges are coming up, and in a large scale, 6-lane tunnels. That might be the largest tunnels below the sea. We are having it. So much of infrastructure projects are going on at a high level. Like and that too in such a highly vulnerable, fragile terrains of Himalayas. Okay, so very very fragile Himalayan terrain. It's such a challenging mixed geological setup. So this ensures, but you need to have a high safety. You might have heard in the recent news like there is a collapse, tunnel collapse. Of course, that is actually contractor issues and other things in terms of practice. But as for the design parts, because I am also consultant to 2 nuclear power plants of my country and several Bharatmala tunnel projects, even now also we have a lot of projects are going on. And when we look at these kind of things, there is like every project is very very different. Okay, so if I'm taking care of some tunnel project in the southern part or in the Western Ghats or in the Himalayas, I have to look at different design philosophies. It's not like I have to go with the same thing. Though the code makes it very very generic. Is that fine? Whether they are following or not following, it can be either 1 or 0, right? I want to be on one side always, not even in between. So, okay, so please make sure that I'm just, passing whatever information and keep me on one side, okay? So, global trends in structural concrete course, because I took bit of structural part as well, because sometimes when we are designing like tunnel design, so we also have to, I think I'm louder enough, I guess. Okay. Design or bridge foundation, we have to deal with something related to concrete, right? So that's why. So let's see. I just took some of the best practices across the globe. So Canada's limit state philosophy. So they adopted. I think we have Alex and colleagues here, so we can correct. Add something over here. They adopted the limit state philosophy, ensuring the safety and the performance of the structures. Then we had ASHTO, and where like most of the US guidelines are based on this. So for bridge code, you can see here the reliability based design approach, which a lot of changes are also happening on this, because they want to use some new materials also, including the geofoam for bridge construction, especially bridge foundations. So because geofoam, if you say that, see, there is something like this. New materials are there, research has went into that, and it's been proved that they are good, but to come into the guideline it takes time. Okay, it takes time. Why? Because if I, as a researcher, if I say that this material worked really well, but please use it, no contractor or no owner want to adopt it, including government, right? Because they want to see the performance in the long term, then only they can adopt. So whatever the Codal provisions we are following, not for today's knowledge that we are following. We are following something which happened 10-15 years before. Okay, that has come into adoption now, right? And now whatever happening in terms of research will come next 10-15 years. Then you can ask me then why we are doing it like backward, why we are still lagging behind in terms of Codal provision. That's where this balance has to be taken care. So research cannot be ignored completely, and there should be. That's why in most of the consulting projects now, what we have is like we have a geotechnical consultant who is basically from IITs and other things where they had a research setup, and they can add value to the project in terms of this. Why? Because it's not just only your performance,
your durability, it's also about your sustainability, and so that whatever the new things coming up can also implement, not completely in the entire project, at least a part of it can go into this, right? Because I'll tell you one other example from my research also. So we are using some, we have two patents, Indian patents as well, and one Australian patent on the particular technology where we are stabilizing the ground using the native bacteria. It's a very, very proven thing right now. It's been happening for the last 10 years, but it's new to the field. Okay, 10 years research is going on, but it's not implemented into the day in practice. Okay, so this procedure is not there. Why? Because we don't have that verified field scale studies. Okay, so what we did is like how to mitigate liquefiable sands and the sales using native bacteria, and which is very, very cost effective, and it's a natural process. We have to learn a lot from the nature. Okay, so right now a lot of things have been there. So how to bring that into the code? So that you don't see that in any of the codes across the globe. Okay, but if you have a person who has done something related, then you can bring them on board. When it's a larger project, then you can see that balance. This is happening even in our high-speed trains. Okay, so when we had it like the designs were failed and the local soils are highly expansive with a lot of heave, and settlements were too much and something like this, then there is a team made, and there's some components of research was also going on. Another example is like how to use geoforms in the bridge foundations, right? This has been happening in the research. You can see a lot of papers in the last 10 years, but if you want to use that, no owner accept, even you don't accept it. If I say something new to build your own house, do you accept? Right? As simple as that. So then that's what I want to say here, growth in knowledge. So there is a knowledge group. So if I look at in the entire thing, perspective, so we have a knowledge group, we have implementing agencies, and there is an industry. So these are three groups which has to work together to make anything successful. So there is a knowledge groups where like research is going on, implementing agencies like Codal provisions, government, these are the and then there is an industry. Industry also has to accept it, right? So they will accept it because our industry, civil industry, don't have time. As simple as that. We can't train our people, right? So many times I think the same scenario with most of the nations, our young kids don't want to go to undergraduate in civil engineering. What is the problem? Civil engineering industry is the biggest industry compared to every other industry combined together. Okay, my daughter joined civil engineering just last year, 6 months before, so I have all the rights to talk on this also. Right? So kids are not, of course I didn't force, so many people think that influencer, no. My husband is a country head for IT company, but still she was keen to go for civil engineering, which is very happy for me, but personal choice. So why do you think? Because we have huge challenges. Challenges are like the next level, but industry don't have time to train our kids to take them. It's not like in IT industry. IT industry take kids and they train for 6 months and they put on the job. But civil industry don't have time because we are having so many projects. No company, I'm not blaming over here. And the knowledge between the academia and the industry, there is kind of gap. They need time, 2-3 years. And as we have in southern part of India, there's a pickle. You make the pickle, after time, the taste enhances. So this profession is also like that. With the time, we are the ones who get highly paid. And if you persistently, consistently working in your domain, at the end of 20 years, after 20 years, so you will be the richest person paid. In our IIT, any IIT as such, civil engineering faculty are the rich people who gets involved in several projects in crores of Indian rupees. So because the problems are there, the challenges are there. So because the kids are, so why I said there are 3 knowledge center, 3 groups which has to be well connected is because everything is connected. And don't say this Codal provisions is a problem. No, don't blame that at all. There is a equal, responsibility from the research group, industry who has to adopt it. Finally, they are the one who has to use it, right? And the implementing agency like BAS, Bureau of Indian Standards, similar to other countries. So they have to. So and then we need to frequently revisit. So it's nothing, as I said, there's a disclaimer. This is a not mandatory. It's just a guideline. It just shows you this is what is best based upon some kind of study. So whatever you can adopt it. If you cannot adopt anything, you can have something flexible. So codes are flexible. I'm sure some of you, anybody here from Indian side? But most of the Nepal office also use Indian codes, right?
Yes.
So if you see that, please make your mind that, because I know Mandakini, we always discuss about the Indian codes and other things. Okay, we are also doing a lot of revision. So most of the things, they are not mandatory. That's what I want to make it. Okay, don't take that this is a Bible or something we have to use. No, nothing is there. So, and it needs a lot of revision. Every year revisions are also happening. Eurocode, I know that how frequently they revised it. Right? Eurocode, I feel like the best thing that happened was like too much revisions have happened, because I was at Stuttgart, the professor was involved with Eurocode. I know what kind of things, how they involved in making that revisions into the Eurocode. So, okay, so how the evolution of the design philosophies, I'll just try to go one by one. Traditional design focus, so initially we centered on only the safety. Okay, factor of safety, right? We only looked at the safety aspects, and then allowable stress methods for structural integrity, etc. Then blending theory development, whatever I said, that's a continuation of this one in a more detail here. And theories like bending theory evolved, where material ductility aspects and other enhancing the flexibility, even it's starting from transportation engineering also, everything. I'm just talking in a more generic way here. And then American semi-empirical approaches came with the European theoretical methods, which showcase diverse practices. And then we have modern codes which reflect historical foundations, emphasizing the importance of past methodologies. And that's what I want to say, that indigenous knowledge has also to be incorporated when you are designing it. And today's design practice combine empirical data, theoretical models for robust engineering solutions. So if you sit within the design office, you have to be as much wide as possible, taking the empirical approaches, whatever the classic mechanics or classic theories say, and then take your codal provision, guidelines, and then local knowledge, and of course plus your creativity. I just want to make an overview of the comparative version. So limit state philosophy infrastructure codes with the Euro codes for standardization in the Europe. So let's go with that first, because as I already said, this is being revised and taken care of many things. So in US, Canada and Australia, they integrated this limit state philosophy into the infrastructure codes for enhanced safety. And these revisions aim to address more modern engineering challenges, taking the materials that are coming up, as I said, geofoam, or some fiber reinforcements, and so also taking care of the past failures. As I said in the starting itself, failures are learning. So that has been incorporated, and the limit state approach, they allows more flexible design while ensuring the integrity of the structure part. And these countries frequently update their codes to reflect advancements in the materials and the construction. So that means that the codal provisions or the implementing agencies are very much involved with the research groups of their country. And then these updates are by need for the improved resilience against natural disasters, obviously for the future. See, whenever you look at it, like in the next, I'm taking 50 years, 2075, as an individual also, as from the Indian perspective also, because we have something called Viksit Bharat. So Viksit in the sense glorious. It's like glorious India. So we have our national policies, national strategies for 2075, so which all of us are to work in line with our national policy. So as a part of that, my HTC also, we made it to Geohazard 2075. If I'm in 2075, what I'm expecting is something which we have to look at it. So that's what is a discussion about. So here, if you see here, for the futuristic surprises, because every disaster is a surprise, and for futuristic multi-hazard, this climate change, because I know I was in Himachal last summer, sometime in July end. Himachal is considered to be one of the very good place. As its name says Himachal, right? It's coolest place, I can say. So I was there for my family trip, thinking that the temperature will be You won't believe me, the temperatures were 42, never in its history. Okay, in Shimla, 42 degrees centigrade. Okay, so I was like, what's happening? Okay, I was expecting, went with my winter wear and me, my family, but when we landed, it was sweating. Okay, so 42. So this is a surprise, right? So this is a climate change, and climate change is so localized. Within few kilometers, there's a change in weather. So microclimate things are also coming up. If I design it for one particular region, like the state of Delhi, okay, if I say that the national capital, even within Delhi, I have like South Delhi, I have a different hazard. I have northeastern part of Delhi, I have a different hazard. So what we have to do is like you have to look at this micro level, hazard, which we already do that for microgeneration studies, etc., etc. Maybe for Nepal also, Kathmandu also. I think I have one student who traveled from university 2 years back. So she did for Kathmandu. So it's a micro level, right? So that means you are taking the site specific thing and defining the hazard. The hazard at this location may not be same level as few kilometers, 2-3 kilometers away, because like the material changes, its behavior will change. So that are driven by the improved resilience against the future disaster. So if I look at the Euro codes for European standards, so they represent a unified set of standards which are harmonizing structural design across the Europe. Okay, I like the Euro codes personally. Okay, why? Because they are trying to make it more broader approach, okay, and taking care of every aspects, including the research part. They facilitate cross-border construction projects and enhance the safety by providing a clear framework. Sometimes, if there is any critical structures, we also, I personally also check it with the Euro codes. Okay, so what I mean to say is like in addition to your national standards, you also has to look at some international standards, because if I'm designing something, assuming that a bridge foundation, okay, the river bridge, okay, which is having its cover or something, I'll check with my IS code, and at the same time I also check with the Euro code. Okay, so then I'll come up with some kind of understanding like what exactly is happening. So Euro codes undergo regular reviews. As I said, revisions were really nice. I think BAS learned from Euro code as well. Like now our revisions are also very frequent. Every 6 months we are having a meetings, technical committee meetings, and we are doing really good. You can see a lot of new changes coming up in our Euro codes also. We have a national building code now, okay, which has been already there. So if anybody have anything related to code, if you have any queries or you have any suggestions for the codes, please write an email to me, because I'm part of BAS. I can take it up. Okay, so these revisions always circulates among the all the people in the country. It's open, suggestions are required. So especially I know that from Mandakini they use IS code. Please look at it. Any suggestions openly you can write to me. We are very happy to have your perspectives also for improvisation. Motivation for updates includes need for sustainable development with the environmental constraints. So this is one of the very crucial thing in any of the Codal provisions at present, taking the sustainability aspects and also for the local needs. Implementing this promotes collaborating among European countries in the several infrastructure projects. So we need updates, frequent updates. Okay, it's not like once in 10 years. That's what happened in our case also now. Like we are doing every 6 months, and it's not easy. And there is some research projects also that BAS is a big agency. Okay, so BAS is giving some research funding for the people in different institutions to work on the codes, come with a new ideas, come with a new solutions, etc. That's where like we need a lot of knowledge groups. We have to integrate that. And then motivation in material research in the materials is happening like in an exponential thing, I can say, because natural materials are depleting. We don't have a sand, right? We have a heavy restrictions with sand, river sand mining in the country, right? So this kind of size of project, where do you get the sand, right? So now people are coming up with M sand, okay, which is like used, and there are of course a lot of risks. So M sand is agreed now. It's similar to that. Instead of using steel, we have fiber reinforced. Okay, and there are so many manufacturing companies coming up with these materials and suppliers, and similar to that we have like all natural materials, because we don't want to use the natural materials because they are depleting in high rate. So So we are going for alternate to reuse materials. We are using plastic in our roads also now, that is acceptable. Okay, so all these things for stabilization of the black cotton soils. So there is a detailed, things have happened with respect to materials and the durability, because if you have a construction, it has to be there throughout its lifetime. Either it is designed for 40 years, 60 years, 80 years, or 100 years. And the durability aspects, especially if you are going for a marine constructions or like some port constructions, or like I was a consultant for one of the offshore monopile, two locations, which is a huge monopile. Okay, which is because we have a API code, American Petroleum Institute code, which can take only up to 3.5 meter diameter, but we designed a monopile that is completely in-house up to 8 meter diameter. Okay, and this is a steel one, right? And if it goes into the marine environment, the corrosion effects and all these things come. So we need to monitor that, corrosion monitoring. So a lot of new things have been coming up, especially with respect to the technological advancements, and that has to go into your code also, right? When I'm going a monopile design or some kind of marine constructions, what should be the suggestions or the guidelines for the contractor, because most of the works are going in EPC mode for us. So the contractor has to handle that project, okay, for including its maintenance for a particular certain period as per the tender document, right? So in that period, if anything goes, we have to suggest that as a client. The client will suggest to him, like, you go, you do monitoring like this, these are the things we needed, regular monitoring. If it is underground tunnel, monitoring the tunnel important, right, for seepage or for displacements and stresses, etc. So that kind of things, you have to focus on this. For durability, you have to involve your advanced technologies that are coming up. Basically, monitoring instrumentation is something I feel like, huge amount of advancements happened in the past. We have like, a lot of companies who are doing this monitoring for major infrastructure projects, and so that, a lot of things can be taken care based on the looking at the thresholds, and decisions can be made, okay, to avoid any kind of risk. Efficiency improvement, innovative technologies which are pushing for codes for efficiency, especially not only construction. See, many times we feel that we have to build something for safer. Okay, it's not only for that time, it has to be there for 60, 80 years. If you're building a project, a bridge, river bridge, so maybe sometime there may be flash flood, right? And you may expect most cover, and do we have any equation who can define that based on hydrological model or whatever it is? At this location the cover will be 10 meters, 18 meters, whatever. Do we have any equation? Any country? How to deal with that? So there, like, I did one of the projects where you have to do a lot of site specific, in addition to geotechnical, geological, that was a marble kind of formation. Okay, geological, geotechnical, hydrological model studies has to be carried out at that site specific. You have to define this is the probable cover that can come up in the extreme flood event in the future, and this is the probability, maybe 5%, whatever you want to take it up based upon your design considerations. Take that and adopt it. Okay, then it will be safer. So otherwise, what happens is, like, in the detailed project report, generally DPRs they'll take 100-year flood. Okay, see, I don't think hydrology as a separate. I always coin this new term, landslide hydrology nowadays, because I feel like this is such a common thing. We cannot work all alone. I'm a geotechnical engineer by training. I can't look things only in the geotechnical perspective. I have to deal with something related to structural aspects, something related to hydrological to make my structure safe, right? It is completely integrated among our sub-disciplines as well. So this hydrology is something which you have to have as a basic information, because most of the landslides you need the hydrological things, tunnel designs for understanding the drainage patterns, you need the hydrological knowledge. So don't look at it, all the undergraduate students or postgraduate students or research students as well here, especially to students, don't look this as some other island which is not to me. So, okay, if you really want to be, doing really good, challenging projects, or if you really want to, evolve as a superstar, or you are preparing for your last job, so you have to take this very seriously now. Okay, so prepare for your last job, not for your first job. Okay, okay. So next one is like efficiency improvements. Like, we need to take a lot of innovative technologies which we have to integrate. So code is not just thing that gives you everything. No. Development of design philosophies in infrastructure. So the same thing. and in a bit different way. So evolution of the design philosophies, then ultimate load factors, limit state philosophy, then risk management integration, where I said like monitoring. There's a systems available now. There are tools available where they also monitor, give you threshold. Okay, if there is any kind of risk. So there are a lot of companies across. In 2026, I'm doing a conference of TC2 under ISSFG conference in Indore. All of you are welcome. I have some brochures which I'll give you tomorrow at the registration desk. So informally, I'm welcoming you all to be at Indore, which is the cleanest city of my country for the last 8 years. Okay, it's a big competition actually. For getting that. So we were winning this for the last 8 years, and so risk management integration. These are the companies which are a lot of data, large big data companies are working on this infrastructure projects. Okay, so let me tell you, civil engineers can hire electronics guys, civil engineers can hire IT people, civil engineers, computer science, data analysts, geologists, seismologists, structural engineers, hydrologists. Okay, so as a geotechnical engineers, you can hire anybody. And everyone also, okay, because you deal with such a large, complex, natural phenomenon. Okay, so for that you need to have. So it's always good to hire, right? So we are giving something. Anyway, global infrastructure standards. These are advancements that transform into most of the global infrastructure. So there are several companies which are working in South Asian countries. Like we have BG, and then we also have several, even in India also there are a lot of Korean companies, Japanese companies, okay, they are working in major infrastructure projects, right? So same as in most of the South Asian countries, like when I was in Sri Lanka last month, so I've seen they have taken me around new Bay Area that they have been developing, reclaiming the land, and so most of the Chinese companies are doing extremely well. Okay, so it is like cross borders, right? So somebody from some country, or even Indian companies are there in Nepal or in China or in Sri Lanka. So everybody are working cross borders. So this kind of global infrastructure standards has to be looked at. So it comes when you have a little bit of information about all the Codal provisions, best practices, and learning from the past failures and how do you implement. As simple as that. Okay, it's not a big thing. And international organizations in Codal development, we have international organizations like CEB, FIP, ACI. Okay, so they all plays very crucial role in shaping the model codes and guidance for national standards. I personally feel this is not there. Maybe I will be bringing this aspect to ISFG also. In terms of international codes, we don't have that kind of platform where I think I'm very happy that how Mandeep and his team got this idea to put a session on Codal practices. When he shared, when he asked me, I want you to talk on Codal provision, I was like, okay, because if it is on landslides, I can talk for a day. If it is on interaction or any other thing, or soil structure interaction, which is my core research, I can talk like in my, comfortable. When he said that, I was feeling okay, but later I realized this is such an important topic, and I feel happy later. Okay, I was given, to do this particular topic because there is a grey part. There is a grey area, okay, and it's always good to talk these aspects in the global platform so that we learn from each other, right? I can learn something, okay, how people are practicing in different projects. So this is not there, especially in ISMG. So maybe I'll be talking about taking this kind of thing in session because we can have representation from 2-3 people from Asian country. We already have such kind of teams for HTC sessions. Similar thing can also work it out for ISMG. See, people can sit together, cross border, because everything now is like you cannot divide now. Okay, we are building like one nation, one planet kind of thing, right? So all of us has to work across this with the global infrastructure developments, model codes. Okay, model codes I can say because these kind of guidelines are very, very crucial. And next one, challenges in the Codal practices in South Asian. I'm just coming. I think till now I just only talked about introduction part. So now I'll just little bit narrow down to the topic. So we have limited research, okay? So including countries like even a lot of research has to go. India, China, whatever big countries, so we have a limited research and we have a lack of centralized directives. Okay, so at least like if I know what are lacking with, then there is a possibility that I can work on, right? So that's why I just put this particular. And depends on foreign codes, many countries they depend heavily is something which I have to put it up here because we also did it and we failed. Okay, so we don't need to do that. So that's what my message over here with my experience in Indian subcontinent. When we use this Japanese code for high speed, designs failed. The company said like, no, we can't do this. Our designs are not working here. Okay, so we have to come with our own design provisions. So heavily we are depending on foreign codes which may not align with the local conditions and material. This is exactly happened for our case. Okay, so you have to you take some best practices, no doubt about it. I am not saying, but you have to integrate that with your indigenous practice, materials, and knowledge. So need for localized solutions. So you need to tailor anything to your project. Okay, everything should be a project-specific design philosophy. Okay, that must be the criteria. Again, I think everything I've talked about Indian scenario, I'm bounded to that. So Indian scenario, Codal provisions, evolving infrastructure codes. So we are updating to meet the modern requirements which are reflecting ongoing evolution. Now I can tell my client, no, I am going to use this particular equation because this is okay. So they are accepting the acceptance rate because in the last 15 years back when I started my career, so there was a lot of resistance, or I can say a lot of things saying that no, code says this, code says that. Okay, so now like no, okay, I always say as my code says this, fine, but is XYZ. Okay, so now they are accepting. So acceptance rate has been increased because of a lot of awareness and guidance from key organizers. We have BAS, we have IRC. Okay, these are the very big agencies in the government. So they do lot of outreach. We have like if there is a new code coming up, we have lot of outreach. Okay, we do lot of workshops. Okay, all this outreach is also happening. Need for central coordination. So we need to ensure the alignment of the codes with the international standards. A little bit of working mode only. It's not completely done, but this is not a just one-time job. It is you have to evolve it. Okay, with the changing climate changes, etc. And successful updates. That successfully we are updating this in several infrastructure codes and have positive. So one more very important point. Even whenever there is any journal, like we have Indian Geotechnical. So we do get only papers from academia. Now what we have done is like we have some special issues for practicing because people who are into practice or industry, they also have done lot of good practices, but that's not documented. Okay, that's not documented. So we need to document our best practices kind of thing. I'm just giving an example like this is something which we have taken as an initiative. So that it can be documented, people can read, the next generation can read and do better. I personally feel, based upon Indian setup, my grandmother is much smarter than me. Okay, seriously, no, I'm very serious because without a proper, whatever we say, the present education system, they are much, better. Okay, I think they might not have gone to a traditional school, college, or IIT, XYZ. But they are much better in doing many things in their own way. Okay, so that what I think in India we have this Indian knowledge systems. Okay, we have to build that. So many things, every nation has that. So I think especially Asian nations all have their own indigenous knowledge in materials, in design, everything. So I think that has to be properly taken care. Areas need improvement. Despite a lot of progress that we are making, certain areas still need a lot of improvement to fully align with the global practices. So of course, as I said, it's an evolving process going on. Okay. Then strategies for advancing codal practice in South Asia. So we need to adopt some of the international standards. So like also implement globally recognized codes because there are very good Euro codes, Euro code 7. Part 5 and other things are very good, which we take it for the safety and performance. Code for local research, I think I talked on every aspect here. And then we have to foster collaborations, that is what I said, like cross-border interactions. Some platforms like this are very, very important, so that we can learn from each other and take the modern practices from other nations as well, and then implement semi-probabilistic philosophy. So like where we can adopt limit state design approach to improve the reliability and the safety in engineering practices. So we have, if you are doing something in some particular software, the client will ask why this software, why not this software, right? Okay. So this kind of things also comes up, right? So you have to justify why you are doing that. So you have to understand this part, because it's not just software. It's a garbage in, garbage out, right? At the end of the day, but you should know what exactly is happening and how the things are working out. Whether you are justified, what you are doing is appropriate, okay? Because every major project we are working is being from the taxpayers' money. All of us, our parents, everybody contributed to that money, so it's highly very important for us to take care of the ownership of our projects. So evaluating the impact of codal practices in the longevity of the major infrastructure projects. So we have practices purely crucial role in determining this infrastructure longevity projects, impacting this durability and the safety in its lifetime. As I said, like offshore monopile design, 8-meter pile, we don't have a code for it internationally also. So we all did that and it's been done. Okay, it's been commissioned, and when we just put that pile, it just went down without anything, just released 2 meter into the marine formation. Okay, 2 meter just with a self weight. Okay, that kind of terrains we had. And statistical analysis, like kind of work we can do it for correlations and coming up with something improvised design. Case studies we can take, as I said, we have to have them, something good practices can be recorded or published, can also be useful. Long-term maintenance costs. Many times we miss this. Maintenance is something which we don't even worry, at least in the Indian perspective I can say very confidently. So I don't know about other countries. So we don't think of maintenance, okay? And in something like if it is in EPC mode or something, it's all burden of the contractor. The contractor, sometimes he do, sometimes they don't do, sometimes there are other issues also, like it's all the stakeholders are equally important for us. It's not like paying is only one, right? No. So that's fine. So we have to update that for also this long-term maintenance cost reduction, because if you can make it in a more sustainable design, I think this maintenance issue will be taken care of partially. So methodologies for codal practice analysis, we need a systematic approach. For doing this, like we have to have a lot of data collection, evaluation, analytical models, then assessment, and then reliable conclusion. So these are the 5 steps you can take it up when you are doing any project design using any type of codal balance perspective. Every time as a designer, you will be balancing something, right? Cost versus durability versus sustainability, right? So you always have this balancing, and it's a good thing to do this also, because if you can do this at home, I think as a woman we all do that every day in, day out, all your mothers have done it. So we lot of balance. There is nothing like a work-life balance actually. I don't think that. It's all like how you manage your time, how you manage your people, right? At home and your office, how you can manage. If you are a good manager, this balance automatically comes, right? So if you see that balancing perspective, this is very, very crucial even in your project design. Okay, so you have to balance whatever the past practices, guidelines provided, materials available, indigenous knowledge available, any kind of environmental conditions are there or constraints are there. So considering everything, you can integrate and work on that so that you can evolve with the best design possible. How much time I have? Please warn me. As a teacher, we have a habit of talking, and myself I talk very fast also. So limit state, modern approach. So it integrated all the methods, combines the semi-probabilistic with the traditionally safety approaches being considered, central to national codes, like cross-border stuff kind of thing we have to look at, so that we can enhance our present codes, material variability. This is going in a very large scale, I feel. Right? Materials, sometimes I feel like I don't even know this material, okay? Okay, so that kind of things are going on. And I think variability of the material is something, new materials especially, something smart materials are coming up. So artificial materials, recycled materials, right? So a lot of materials are coming up now, and load uncertainties have just some. See, we had one project. There was like hood. It was like a kind of flood that happened in the coastal Andhra Pradesh, which is it's my own state. So in the south part of the country, there was an airport in Visakhapatnam. It's a port city, and the top of the airport has completely gone. Okay, because there was never expected that much high wind in its history. Okay, in the past history never happened that much wind. So it happened one day. Okay, and when I visited after failure, I don't know. Every time a project failed, after it got failed, I will be asked to come. Or they put me in fact finding committee after some failure. I think that's made me to like this failure photographs, I guess. Because I'm working with the failures. I always wonder why they don't call me before, why they always call me after. Anyway, so this uncertainties, load uncertainties, right? We are having the tallest bridge in the world, right? China Bridge. So we have that, we build that, we commission. So this having huge wind loads and seismic and the border between Indo-Pakistan. Okay, so several challenges we had it, right? So all these things when we could handle it up, so that's all because of having a holistic approach in your design philosophy. Next one, robust risk assessment, flexible framework. So your design team, see, design is not just, I always say my students, undergraduate students, it's a trial and error. Design is a trial and error, right? You do, doesn't work, add, remove, you have fun with it, right? Always fun, right? So if I give same design to two people, I'll get two different things, right? Because they are taken different consideration. Don't expect that, see, sometimes, we always get this kind of thing. Major projects, government engaged two groups also. Okay, one from the contractor side, one from the client side. So they always want, and both are from top institutions they will hire. Okay, so like IITs or something. So when you have it, like there will be some change, and then across the table we sit and discuss. Oh, the depth was less here, depth was more here, thickness is less here. So they compare with this. Why this one? The philosophy goes in, right? What kind of philosophy the designer has adopted, what kind of methodologies they adopted, it's all different. So design is a trial and error. Just start with it. So you can go, changes, because sometimes what happens, you had some material or some investigations you have done, some changes happened, but some cavity came or something. Okay, you need to relook it. International code harmonization efforts, lot of global collaborations. That's what I'm going to bring tomorrow, discuss with Mark also, he'll be here today. So we need a lot of inspiration for Asia, and we are all, have to work together. And this is very, very important for Asia, because most of the risk, so I feel like more than 50% risk is concentrated in the Asian countries, especially with the geohazards. So and population, because risk is higher, right? Population is more. Habitation is more. So obviously high risk is concentrated in the Asian terrain. So we have to work, and that needs a lot of inspiration for us and shared innovations. So thanks to you for having me here. It's a chance to learn from you, and we can take some standards that are already available, Eurocode examples, etc. Challenges in updating the Indian codes. Let me come with our challenge: dependence on foreign codes, which we are slowly reducing it. And I can say 50% to 60% we already achieved our own things. Fragmented efforts were there. We had a lot of redundancy was also there. A lot of duplications were also there in few codes. So that we worked it out. Voluntary committee structures were being made. So people across the country are working on that. Progress in the codes. So significantly we changed, but a lot to go for it, and a lot of coordinated research. Research is something which you cannot ignore in civil engineering. Every project has a part of research component. Don't think that research is somebody who has a Ph.D. or who do Ph.D. only do. They came from some other planet, nothing like that. Research always goes into your practice. So please keep that in your minds. Always keep this. You have some research component. Put your creativity. Don't close that. So don't shut your creative door, and then sit and see how best you can make your design more durable, and considering the futuristic challenges. So new strategy, I just took a bridge code here as one example. Like seismic code also similar example I have. So unified design philosophy, limit state philosophy, which can provide a lot of flexibility. Common design principles like standard practices has been taken care to have consistency among the practitioners, and material knowledge, updating that, and new technologies, streamlining some developments happening, facilitating the future updates. I can leave this presentation with Mandeep. You can check it with him and take it up. Nature and role of engineering codes. So it is distinct from textbooks. Textbooks have been made at least 30-40 years back. And all our textbooks are of this much size. I told this to my daughter. When she decided to go for civil engineering, I said, see, the textbooks I studied were this much, what your father studied were this much. Okay, he just studied 1/4 of what I studied in a particular topic. You also may have the similar. Computer science, the textbooks of this much size. I have a textbook of mechanics is this much size. Building materials is this much size. I don't know about your nation, but mostly civil engineering textbooks are, every book is like almost 2 kgs. Okay, right? And computer science books are like this, right? Because we are very bored. We have a lot of things to learn in that 4 years, which is not sufficient for me, I feel. Anyway, so, and what we learned in 4 years is just an introduction. And you cannot expect a 4-year graduate guy to just go into the field, taking so much risk, okay, and build something which, he can go to jail if something goes wrong, right? So that much of risk he is taking. So, and then guidance for design, scope definition, meeting modern challenges. So all these things are something, which you have to understand if you really want to function with the practices that's happening at present day life. Okay. Again, something similar, but little bit extra things like eco-friendliness. As I said, like you have to always look for what kind of, how much percentage of material is coming natural, local material, so that we have the sustainable practice. Sustainability, like UNDP goals are something taken very seriously, and which we are doing it, use of plastic, use of local materials, bamboo, etc. Only in India we have around 2000 plus varieties of bamboo. Okay, and we have bamboo reinforcement now, came to steel, replacing steel, so a lot of things, especially, and landslides also a lot of bamboo and natural. There is a type of grass which generally grows in some parts in the eastern Ghats of the country. So we want to use that for stabilizing the erosion, mitigation the erosion effects, etc. So this is a small case study for IRC limit state concrete code. So it's a unified approach. The code, exemplifies a comprehensive framework which you have happened to. I'm just giving you a homework kind of thing. If you have time, go to the. You can take any code, but I just put it here. And for these, each one you just see how can you write your understanding on each one of this. Okay, for this particular code. So IRC limit state concrete code, material properties, like there's a detailed specifications on the properties for its safety and the performance during its entire life period, load combinations. So many times this is very tricky also. Sometimes people take earthquake load, sometimes they don't take, and they have justification. It is in seismic zone 2 or seismic zone 3, never happened earthquake 100 years. Whatever it is, you have to take very, very balanced approach as a designer. Pre-stressing practices, this is also common because you need to have fast constructions, right? Low cost, fast construction is something deadly combination which client always look for, right? So you always have a low cost and it should be done cut off. So normative, informative annexures, and you need to update with a lot of data, guidance, the structure of the code that support through a lot of interpretation, aiding engineers in effective application, innovations, and the durability as a major focus, along with the sustainability. International platforms for knowledge exchange, something like this. We also want a lot of this. This is lacking, I personally believe. I'm doing in the Indian perspective, but I really want to look at in the international perspective also. We need to have a code which can take care of cross borders, at least in the Asia, okay, or South Asia more specifically, or at least I can say that in this particular region, this code works. This is something can be a best practice. So how can to evolve that? For that, a lot of interactions are required, a lot of participation is required among the South Asian nations, and and with bringing a lot of innovations and research into your knowledge. So what next? Path forward. Okay. So we need international harmonization. local research development. We need to work on local, groups to reach. You have to carry out your research on a local problem and just try to bring that, bottom to top approach. So new generation codes, coordinated national efforts, and of course challenges at the local scale has to be considered. Okay, so there should be a bracket where your local challenges can be addressed in your common code or global code. So takeaways, okay, continuous learning. Sorry, I'll just come from the first one. We have to update our codal practices that we are doing and should align with the best international practices. And limit state philosophy, we can adoption of this limit state philosophy in our infrastructure design is something very, very important. Region specific codes, okay, any particular specific region, a lot of collaboration efforts, okay, okay. We are comfortable in our own skin, so we don't want to come out, and then which has to be if you really want to grow, cross borders, cross nations, collaborations, learning from each other. Learning from each other is something I feel like this is the important aspect that we have to focus on, and improving each other. There should be give and there should be take away as well. So continuous learning can happen with that collaborative approach. So future directions for the codal development. AI, okay. I don't know what to say for this. I don't know whether it's a friend or an enemy. It's everything for us right now, right? People stop writing emails also. People always check you use something, let me know now. Otherwise it is very difficult to figure it out also, right, when you are using some AI tool to write. Anyway, that's okay. We have a positive part of it. You can adopt some of these IoT technologies especially for monitoring, remote monitoring, and to enhance the safety, efficiency, because I can't go below the sea and see monitoring how my tunnel is working out, right, or how my foundations for some offshore, pile or something going on. So adapting to new materials, global local engagement. I think I talked a lot about global local engagement and sustainable progress. So fostering this sustainable long-term success in South Asian infrastructure projects is something coming up. Discover the impact of codal practices. So we have to learn how to implement the strategies, how to implement our research outcome, and considering our local challenges with the local materials and the knowledge. I think I'm done with that. So I don't know why I don't have a thank you slide.